Hello everybody, let's begin with the discussion of the questions over quadrilaterals. The first question says that the angles of a quadrilateral are in this particular ratio. Obviously in a quadrilateral there are 4 angles, that is why these 4 numbers are given to you. Find all the angles of that quadrilateral. So I am given that suppose this is my quadrilateral, any quadrilateral I take. Say angle A is to angle B is to angle C is to angle D is what is given to me as 3:5 is to 9 is to 13. This implies, what can I write? By the concepts of ratios and proportions, we know that angle A will be written as 3x, angle B as 5x, angle C as 9x and angle D as 13x. By the angle sum property of a quadrilateral, I know that angle A plus angle B plus angle C plus angle D is 360. So, by angle sum property, angle A plus angle B plus angle C plus angle D is 360. Angle A plus angle B plus angle C plus angle D means 3x plus 5x plus 9x plus 13x is 360, right? What does this give you? This is 8, 8 plus 9 is 17 and 17 plus 13 gives you 30. So 30x is 360, so x is 12. If x is 12, you know what is angle A, angle B, angle C and angle D. Angle A will be 3 into 12 which is 36. Angle B will be 5 into 12 which is 60, angle C will be 9 into 12 which is 108 and angle D will be 13 into 12 which is 156. So these are the 4 angles of your quadrilateral. Next I have, show that if the diagonals of a quadrilateral bisect each other at right angles, then that quadrilateral is a rhombus. Okay. So we have a quadrilateral, it is given to us that the diagonals of that quadrilateral are bisecting each other at right angles. So I have a quadrilateral, this is A, B, C, D. These are the respective diagonals. The diagonals would be AC and BD. AC and BD would be the respective diagonals of this very quadrilateral. So I have AC diagonal and I have the BD diagonal. They are bisecting first of all. That means AC diagonal is bisecting BD diagonal into 2 halves and BD diagonal is bisecting AC diagonal into 2 halves. Right? And they are bisecting each other at right angles. Clear? This is what is given to me. I have to show this is a rhombus. To show this is a rhombus, what is it I have to show? It is a parallelogram whose all sides are of equal length. So I have to show A, B, C, D is a parallelogram with all sides equal. So first of all, focus upon these 2 triangles AOB and DOC. You know that AO is equal to OC. BO is equal to OD and you know that these 2 angles, say angle 1 and angle 2, these 2 are equal to each other, not just because they are vertically opposite angle, of course that is a reason, but here the measure is also given, it is same, that is 90 degrees. So I have angle 1 is equal to angle 2. Therefore by SAS congruence rule, I have these 2 triangles congruent to each other. Which ones? So you can see B is corresponding to D and A is corresponding to C. So you have A is corresponding to C, B is corresponding to D and obviously O is corresponding to O. So I have triangle OAB is congruent to triangle OCD and therefore their corresponding paths will be equal. So I will have angle OAB is equal to angle OCD first of all. This angle will be equal to this angle. Reason is CPCT. If you can carefully observe, this is like these are two lines being intersected by a transversal AC, making this pair of alternate interior angles equal, and therefore these two lines are going to be parallel to each other. So I have, these are actually alternate interior angles. So AC is the transversal intersecting the two lines AB and CD, making a pair of alternate interior angles equal. So AB is parallel to CD. Exactly on the similar lines, you can show AOD triangle is congruent to BOC triangle. From here, you will have that ADO angle will be equal to this angle, and therefore AD will be parallel to BC. Right? AD will be parallel to BC. So similarly, AD is parallel to BC. Exact same argument replicated for these two triangles. Just like we have done for these two triangles and proved these two sides are parallel, exact same argument replicate for these two triangles congruence and conclude that these two sides are parallel. A quadrilateral in which opposite sides are parallel is a parallelogram. So therefore ABCD is a parallelogram. Now you focus upon these two triangles. This part is done. I have to show all sides are equal. Focus upon these two triangles, okay. In these two triangles, you can see AO is equal to OC. AO is equal to OC. This angle and this angle, they are same as 90 degrees. So angle AOD is same as angle COD. Because it's given to me that they are bisecting at right angles. So this is 90. And I have OD common in both these adjacent triangles. So OD is equal to OD. So obviously I have O corresponding to O, D corresponding to D, and C corresponding to A. So I have by side angle side congruence rule, by SAS congruence rule, I have triangle AOD is congruent to triangle COD, and this is going to give me AD is same as CD because of CPCT. So I have AD's measure is same as CD's measure, but because ABCD is a parallelogram, therefore opposite sides are of equal measure. So whatever is the measure of CD, same is the measure of AB. Whatever is the measure of AD, same is the measure of BC, thereby giving me that all the four sides of this quadrilateral are of equal measure. AD is equals to CD, but AD is equal to BC and AB is equal to CD. Because of 1, this is my 1, right, by 1, I'll write by 1. Therefore, AB is equal to BC is equal to CD is equal to AD. This is 2. So I have ABCD as a parallelogram in which all sides are of equal measure, and therefore this is also accomplished, and I have shown what I had to show. ABCD is a rhombus. Clear? Next we have two parallel lines L and M are intersected by a transversal P. Okay, so a transversal is intersecting two parallel lines. It's already given to me that the lines are parallel. Show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So these are actually bisectors, okay. These are bisectors. They are bisecting the respective angles. I have to show this ABCD that you can see, which is formed by the bisectors of the respective angles, is actually a rectangle. Understood? What will be a rectangle? I actually have to show that ABCD is a parallelogram with all angles of 90 degrees. This is what is a rectangle. Now see, because L is parallel to M, this complete angle and this complete angle, they are equal because they are alternate interior angles. So L is parallel to M. This implies angle LAC or PAC is equal to angle ACR. Why? Reason is alternate interior angles. If these two are equal, this implies their halves are also equal. Half of angle PAC, because this AB is the bisector of this angle, half of angle PAC is this angle, angle 1, and because CD is the bisector of angle C, so half of angle ACR is this angle, angle 2. So half of angle PAC is angle 1 and half of angle ACR is angle 2. Now carefully observe the situation over here. You have this line AB, this line CD, fine, you have this line AB, this line CD, and this line is acting as a transversal, this line P is acting as a transversal, intersecting the lines AB and CD at two distinct points A and C, making a pair of alternate interior angles equal, and therefore AB line will be parallel to the CD line. Because these two are, which are alternate interior angles, therefore AB is parallel to CD. Exactly in a similar fashion, you can see that because L is parallel to M, this angle and this angle, they are alternate interior angles which will be equal, right? And therefore their halves are also going to be equal, which is going to imply what? If their halves are going to be equal as well, what is the half of this angle? It will be this angle. Angle 3 is half of that complete angle, and this is angle 4, right? Half of this big angle. So if these two angles are equal, their halves are also equal. So angle 3 is equal to angle 4. Angle 3 is equal to angle 4 implies that, what is true? Angle 3 is equals to angle 4 implies that CB and DA are the lines being intersected by the transversal P, making a pair of alternate interior angles, angle 3 and angle 4 equal, and therefore AD is parallel to BC. So exactly on the similar lines, similarly AD is parallel to BC. The moment I have opposite sides parallel, I have the figure is a parallelogram. This implies ABCD is a parallelogram. Now that ABCD is a parallelogram, I know that, let me rub this, I know that these two lines are parallel and P is a transversal, so this angle plus this angle is 180 because they are forming a pair of co-interior angles. So I have angle PAC plus angle ACQ. Angle PAC plus angle ACQ is 180 because they are co-interior angles. Therefore, half of this plus half of this is half of this. So half of angle PAC plus half of angle ACQ is half of 180, that is 90. Half of angle PAC is this angle, angle BAC. Half of angle ACQ, half of angle ACQ is this angle, that is angle ACB. This is 90. The moment I have this angle plus this angle is 90, I consider the triangle ABC. In triangle ABC, by angle sum property, I know angle ABC plus angle ACB plus angle BAC is 180 by angle sum property. Here I have BAC plus ACB. BAC plus ACB is 90, so you have angle ABC will be 180 minus 90, that is 90. So you have got that this angle will be equal to 90 degrees. So you right now have this situation with you. ABCD is a quadrilateral. Say this is A, B. I'm separately drawing that quadrilateral which is given in the figure. ABCD is, first of all, we have proved is a parallelogram in which one angle is coming out to be 90 degrees. Because this is a parallelogram already declared, that means AB is parallel to CD, right? AB is parallel to CD and BC is acting as a transversal then. So angle B plus angle C will be 180 because they are forming a pair of co-interior angles. If angle B plus angle C is 180, angle B is 90, that means angle C will also be 90. Right? So angle C has come out to be 90. Now because ABCD is a parallelogram, opposite angles are equal. So angle C will be equal to angle A and angle B will be equal to angle D. So you will get all the angles out of 90 degrees. So you have established that ABCD is a parallelogram, one angle is 90 degrees. This implies each angle is of 90 degrees. And therefore a parallelogram in which each angle is of 90 degrees is clearly a rectangle. Let's talk about the next question. It says that ABC is an isosceles triangle. Okay. So you are already given ABC is an isosceles triangle. AB is same as AC. The moment AB is same as AC, that means this angle will be equal to this angle because angles opposite to equal sides are equal. Now if you carefully observe triangle ABC, this complete angle is an exterior angle of this triangle. So I will have angle PAC is equal to angle ABC plus angle ACB. Why? Because of exterior angle axiom. That exterior angle is equal to sum of opposite interior angles. But it is given in the question that AD is bisecting PAC. AD bisects PAC. Bisects PAC means if this is angle 1, this is also angle 1. Both these are equal. AD is bisecting this complete angle, angle PAC. So I have angle PAC will be written as angle PAD plus angle DAC, right? Angle PAD plus angle DAC, but angle PAD is same as angle DAC. So I will write PAC as angle DAC plus angle DAC. And if I talk about these two angles, angle ABC plus angle ACB, these two are equal because angles opposite to equal sides are equal. So this plus this can be written as this plus this, right? Angle ABC is same as angle ACB. So I will write here ACB plus angle ACB. So you will have twice of angle DAC is equals to twice of angle ACB. This means angle DAC is equal to angle ACB. You have proved the first part. Now if you have shown that angle DAC is same as angle BCA, that means this angle you have shown equal to this angle. What have you shown? It's like these are the two lines being intersected by the transversal AC, making one pair of alternate interior angles equal, and so these two lines AD and BC will be parallel. So these are equal, which are alternate interior angles, and therefore AB will be parallel to CD. Already it is given in the question that CD is parallel to AB. We have proved BC is parallel to AD. Yes, so we have proved from here BC is parallel to AD. And we already have AB is parallel to CD. So a quadrilateral in which opposite sides are parallel is a parallelogram. So we have shown this also, and therefore ABCD is also a parallelogram. Next question, let's see, says what? Diagonal AC of a parallelogram ABCD bisects angle A, show that it bisects angle C as well. Now you are already given that it is a parallelogram, right? That means AB is parallel to CD. AB is parallel to CD. So this angle will be equal to this angle because they are alternate interior angles. So this is angle 1, this is angle 2. Moreover, you also have AD is parallel to BC, so you will have this angle is equal to this angle. Say this is angle 3 and this is angle 4, again because of alternate interior angles. So I can say angle 1 is equal to angle 2 and angle 3 is equal to angle 4, alternate interior angles, right? But 1 is equal to 3 because AC is bisector of angle A. So 1 is equal to 3. This implies 2 is equal to 4. Therefore, AC bisects angle C. Right? Show that it bisects angle C. We have shown ABCD is a rhombus. Now, the fact that you already know it's a parallelogram, I only need to show that all the sides are of equal length for declaring it to be a rhombus. So now I have angle 1 is same as angle 2, angle 3 is same as angle 4, but angle 1 is same as angle 3, so angle 2 is same as angle 4. This implies what? Angle 3 is also same as angle 2, because 1 is same as 3, 1 is same as 2, so 2 is same as 3. If 2 is same as 3, sides opposite to equal angles are equal, so I will have these two sides will be equal. This implies AD will be equal to CD. You can write the reason that because sides opposite to equal angles are equal, and ABCD is a parallelogram, therefore opposite sides are of equal measure. So CD will be same as AB and AD will be same as BC, thereby implying that all the four sides will be of same measure. AD will be same as CD and AB is same as CD and AD is same as BC. Since ABCD is a parallelogram. Therefore, AB is same as BC is same as CD is same as AD, and a parallelogram in which all sides are of equal measure is a rhombus. Next question. This is a trapezium in which AB is parallel to CD. Okay. So it's already given to us that AB is parallel to CD, and we are also having that AD's measure is same as BC's measure. Show these things. I have to show angle at A is same as angle at B, angle at D is same as angle at C. These two triangles are congruent, diagonal AC is same as diagonal BD. So in here basically this is the construction that you have to do. You are only given the trapezium. What do we do the construction? We extend the line segment AB to such a point E such that when I join CE, it is parallel to AD. So the construction says CE is parallel to AD by construction. Fine. AD is parallel to CE. Already it is given to me that AB is parallel to CD. I am extending AB, so that means AE is also parallel to CD. Fine. So here you can see this complete figure AECD is a parallelogram because opposite sides are parallel. So it's a parallelogram. Now the fact that it's a parallelogram makes me do what? See, AD is same as CE because in a parallelogram opposite sides are of equal measure. So you get AD is same as CE. But AD was same as BC, so you have got CE is same as BC. Angles opposite to equal sides are equal, so you get angle CBE. Angle CBE is same as angle CEB. Why? Because angles opposite to equal sides are equal. Now because this complete figure is a parallelogram, I know angle at A plus angle at E is 180 because they are co-interior angles. So we have angle at A plus angle at E is 180. Why? Because AD is parallel to EC and AE is like a transversal. So angle at A plus angle at E will be 180 because they are co-interior angles. Right? And you know that angle, this angle and this angle, this will also add up to give you 180. Why? Because they are forming linear pair of angles. So angle ABC plus angle EBC is 180. Also because angle at E is same as this angle, that is angle EBC or CBE. You know that angle CEB is same as angle CBE. So this actually becomes angle at A plus angle CBE is 180. Because CEB is same as CBE, because angles opposite to equal sides are equal. So instead of CEB, I can write CBE. Right? So what is it that I have? From 1 and 2, I get ABC plus CBE. ABC plus CBE is 180. Angle at A plus CBE is 180. So basically I get angle ABC plus angle CBE is equal to angle at A plus angle CBE. Angle CBE cancels out. You are getting angle ABC is equal to angle at A. That means angle ABC is equal to angle at A, and that is what you had to first of all show, that this complete angle at A is equal to this angle at B. Now you have to show angle C is equal to angle D. Clearly observe, because AECD is a parallelogram. Now consider AE is parallel to CD, which it is true, and AD is acting as the transversal. So angle at A plus angle at D will be 180, and similarly angle at B plus angle at C will also be equal to 180, isn't it? Because AE is parallel to CD and BC is acting as a transversal. So angle at B, this angle plus this angle will also be equal to 180. So I have angle at A plus angle at D is 180, and angle ABC plus angle DCB is also equal to 180. But angle at A is same as angle ABC, so this cancels out. You get angle at D is same as angle DCB. So you have got that angle at C is also equal to angle at D. Now you have to show that these two triangles are congruent. Which two triangles are congruent? When you join these two and you join these two ends, you get triangle ABC is congruent to triangle BAD. So these two triangles you have to show congruent, which is very easy. Why? Because this angle is equal to this angle, right? This side is already given to be equal to this side, and this is common to both the triangles. So by Sas Congruence Rule they are congruent. The moment they are congruent by CPCT, both these AC and BD are corresponding parts of these two congruent triangles, so they will be equal, thereby implying that the diagonals are equal. So you will write that AB is equal to AB, angle DAB, that is angle at A, is equal to angle ABC. We have proved that angle at A is same as angle at B, and AD is same as BC. This is given to me. Therefore, by Sas Congruence Rule, triangle ABD, or I should say ABC, is congruent to BAD. Thereby implying that AB is same as BA, BC is same as AD, AC is same as BD. I need AC is same as BD. Because AC is and BD are the two diagonals, and therefore I have got, as a result of their congruence, the diagonals are equal. Moving to the next question, we have in a parallelogram. So this is a parallelogram. E and F are the midpoints of side AB and CD respectively. Okay. F is the midpoint, E is the midpoint. Show that the line segments AF and EC trisect the diagonal BD. Show that the very line segments AF and CE trisect the diagonal BD. That means I have to show DP is same as PQ is same as QB. That is what I have to show. That DP is same as PQ is same as QB. I have to show this. So what I do, let us just see. AB is parallel to CD. And therefore, any part of AB is parallel to any part of CD. So, I have AE is parallel to FC. Also, in a parallelogram, opposite sides are of equal measure. So, I know that AB's measure is same as CD's measure. This implies half of AB's measure is equal to half of CD's measure. Because E is the midpoint of AB, half of AB is AE. And F is the midpoint of CD, so half of CD is FC. So, I have got AB is parallel to FC and AB is equal to FC. If in a quadrilateral, you can clearly see FAEC is a quadrilateral. In a quadrilateral, if one pair of opposite sides is parallel and equal, then that quadrilateral is a parallelogram. So, by this and by this, I get AECF is a parallelogram, and this implies AF is parallel to EC. Fine. The moment I have AF is parallel to EC, I have any part of AF is parallel to any part of EC. So, I have PF is parallel to QC. PF is parallel to QC. Focus in the triangle DQC. In this triangle we have, as I just said, PF is parallel to QC. Try to remember the midpoint theorem. F is the midpoint of CD. From the midpoint of one side of the triangle DQC, the line segment which is being drawn is parallel to another side QC of the same triangle. So, that line segment will be intersecting the left out side at the midpoint only by the midpoint theorem's converse. Fine, because F is the midpoint and the line segment from F is parallel to QC. So, this line segment will be intersecting the other side of the triangle DQC at the midpoint. So, by the converse of midpoint theorem, P will be the midpoint of DQ. Therefore, by converse of midpoint theorem, what do you have? P is the midpoint of DQ. So, DP is equal to PQ. Exactly in a similar sense, if you focus upon triangle APB, as you just said, AF is parallel to EC, therefore any part of AF is parallel to any part of EC. So, AP is parallel to EQ. The moment AP is parallel to EQ, you should realize that E is the midpoint of side AB of the triangle ABP. Okay. From here, the line segment that you are drawing is parallel to the EP side of the triangle. So, it will be intersecting this side, PB side, at its midpoint only by the converse of midpoint theorem. So, Q will be the midpoint of PB. Then, by converse of midpoint theorem, I have P or Q is the midpoint of PB. So, I have PQ is equal to QB. So, I have DP is equal to PQ, but PQ is equal to QB. So, DP is equal to PQ is equal to QB, which I had to show, and that is what completes the proof of this. 8th question says ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that ABCD is a square. So, I have this rectangle with me, A, B, C and D. AC bisects angle A as well as angle C. So, I have this is angle 1, this is angle 2, this is angle 3, this is angle 4. Because AC is bisecting angle A, so angle 1 is same as angle 2 and angle 3 is same as angle 4. Please understand, because this is a rectangle, each angle is of 90 degrees. So, complete angle A is equal to complete angle C, which is 90. So, half of angle A will also be equal to half of angle C. If angle A is same as angle C, so halves will also be equal. So, angle 2 will be same as angle 4. If angle 2 is same as angle 4, sides opposite to equal angles are equal. So, you get AD is same as CD. But in a rectangle, opposite sides are equal. So CD is same as AB and AD is same as BC. Fine. But AB is same as CD and AD is same as BC. Right? So eventually you get AB is same as BC, is same as CD, is same as AD. A rectangle in which all sides are equal is a square. So therefore you get ABCD is a square. Next I have to show diagonal BD bisects angle B as well as angle D. So if I draw this diagonal, I have to show it bisects angle B as well as angle D. Because this is a rectangle, I know this angle is equal to this angle, right? This angle is equal to this angle. Moreover, because this side is equal to this side, so this angle is also equal to this angle. Are you understanding? Angle 4 is equal to angle 5, but angle 6 is also equal to angle 5. That means angle 4 is equal to angle 6. What did I say? Angle 4 is equal to angle 5 because they are alternate interior angles. And angle 4 or angle 5 is equal to angle 6 since BC is same as CD and angles opposite to equal sides are equal. So this gives me angle 4 is equal to angle 6. That means BD is bisecting angle B. Similarly, angle 6 is same as angle 7 because of alternate interior angles, right? But angle 7 is same as angle 4 because AB is same as AD, so angles opposite to equal sides are equal. So if angle 6 is same as angle 7, right, and angle 4 is same as angle 7, what are you getting? Or I should say, rather than that, angle 7 and angle 5 will be equal. Why? Because angle 7 is same as angle 6 and angle 6 is same as angle 5. Right? Angle 6 is same as angle 5, I concluded, right? So angle 6 is same as angle 5 because angles opposite to equal sides are equal, and angle 6 is same as angle 7 because they are alternate interior angles. That means angle 7 is same as angle 5. Similarly, angle 7 is same as angle 5. And therefore, you have got that BD bisects angle B as well as angle D. Next I have, show that the bisectors of angles of a parallelogram form a rectangle. Let's see. I have a parallelogram. I have a parallelogram A, B, C, D. Bisectors of angles of a parallelogram. This is a bisector. This is a bisector. Then you have, this is a bisector. Let me extend this. And you also have, this is a bisector. So extend this. I have to show this figure that is being formed. So this is P, this is Q, this is R, and this is S, is a rectangle. Now see, these are angle bisectors, so I have angle 1 is same as angle 2, angle 3 is same as angle 4, angle 5 is same as angle 6, and angle 7 is same as angle 8. And they are halves of the respective angle. Okay. If I talk about angle 1 plus angle 3, it is half of angle, what is this angle 1? Half of angle A, and angle 3 is half of angle D. So it is half of angle A plus angle D. Because this complete ABCD is a parallelogram, complete angle A and complete angle D are co-interior angles, so their sum is 180 and half of 180 is 90. So you get that angle 1 plus angle 3 is 90. In the triangle ASD, angle 1 plus this angle at S plus angle 3 is 180 by angle sum property. So angle 1 plus angle 3 plus this angle at S is 180. So what is this angle at S? 180 minus 90, which is 90. So this angle is coming out to be 90. But this angle and this angle, they are all vertically opposite angles. So even this angle will be 90. Fine. What did I say? Angle 1 plus angle 3 plus angle ASD is 180. by angle sum property. But angle 1 plus angle 3 is 90. So angle ASD is 180 minus 90, which is 90, which is same as angle PSR, because they are vertically opposite angles. Exactly in a similar way, this will be 90, and so you will get this is also 90. Similarly, you will get this is also 90 and this is also 90. Okay? So you have in quadrilateral PQRS, angle P is equal to angle Q is equal to angle R is equal to angle S, which is 90 each. I am talking about internal angles PQRS. This means each angle of this quadrilateral is 90 degrees. Can I say it's a parallelogram? For that I have to show some criteria which can help me conclude that it is a parallelogram. So I know that if in a quadrilateral both pairs of opposite angles are equal, then it's a parallelogram. So here in this PQRS, you can see angle Q is same as angle S, one pair of opposite angles are equal, angle P is equal to angle R, another pair of opposite angles are equal. So as both pairs of opposite angles are equal, therefore PQRS is a parallelogram, and the moment PQRS is a parallelogram with each angle as 90 degrees, it is a rectangle. Okay? Let's talk about the next question. I have ABCD is a rhombus and PQRS are midpoints of ABCD. Let's talk about this now. So I am already having ABCD is a rhombus. Let's talk about this question. A, B, C, D. I have P, Q, R as are midpoints of AB, BC, CD and AD. Show that the quadrilateral PQRS join P and Q, R and Q, S and P, S and R. Show that this quadrilateral formed is a rectangle. Fine. What I am going to do is I am going to join B and D. Okay? Or you can also join A and C. Let them meet at O. Carefully see P and Q are midpoints of side AB and BC. If you consider the triangle BAC, the line segment joining midpoints of any two sides of the triangle is parallel to the third side and is half of it. So PQ is parallel to AC and PQ is half of AC. Reason is midpoint theorem. Exactly in a similar way, if you consider the triangle ADC, you again have R and S are midpoints of two sides of the triangle ADC. So the line segment joining them is parallel to the third side. So I will have RS is parallel to AC and RS is half of AC. We have proved this. PQ is parallel to AC. Here also the reason is midpoint theorem. PQ is parallel to AC, RS is parallel to AC, so this implies PQ is parallel to RS and PQ and RS both are equal to half of AC, so that means PQ is same as RS. In the quadrilateral PQRS, there is one pair of opposite sides which is parallel and equal, and therefore it is a parallelogram. This implies PQRS is a parallelogram, which further implies even PS is parallel to RQ. Or you can also say, because in the triangle ABD, PS is the line segment joining midpoints of two sides, it will be parallel to the third side BD, and RQ is the line segment joining midpoints of the two sides of the triangle BCD, so it will be parallel again to BD. So both these are parallel to BD and therefore they are parallel to each other. And also they are also equal in length, because both are equal to half of BD by midpoint theorem. So I have PQ is same as RS and PS is same as RQ. This complete figure is a parallelogram. Opposite sides are equal and opposite sides are parallel. I have to show that each angle is of 90 degrees. What I do is I consider this particular figure. Consider this. This is say M and this is N. Consider this figure. Okay. You know complete RQ is parallel to BD, so any part of RQ is also parallel to any part of BD. You can say this is a part of RQ and this is a part of BD, so I have both these are parallel. QN is parallel to MO. Similarly, you know that PQ is parallel to AC, so any part of PQ is parallel to any part of AC, so you have this is a part of PQ and this is a part of AC. So you have MQ is parallel to ON. You can clearly see in this quadrilateral MONQ opposite sides are parallel. So therefore MONQ is a parallelogram. If it is a parallelogram, opposite angles are equal. So you will have this angle is same as this angle. So you will have angle MON. Therefore angle MON is equal to angle MQN. But you should be very nicely aware about this fact that if you know ABCD is a rhombus and AC and BD are its diagonals, then diagonals of a rhombus always intersect at 90 degrees at right angles. Each angle over here is 90. So you should know that MON is always going to be 90 degrees because the figure given is a rhombus and the diagonals of a rhombus bisect each other at 90 degrees. They intersect each other at 90 degrees. This is 90, so even this will be 90. And so I have PQRS is a parallelogram with one angle 90 degrees, and I showed you if you have PQRS is a parallelogram with one angle 90 degrees, then each angle will be 90 degrees because you know that this is parallel to this and QR is a transversal. So angle Q plus angle at R will be 180. So angle at R will be 90 because it is a parallelogram. Opposite angles will be equal. So even this will be 90 and this will be 90. So if it is a parallelogram with one angle 90 degrees, then it is a rectangle. So I have got MQN as one angle of the parallelogram, PQRS as 90 degrees. So I have by 1 and 2. By 1 and 2, PQRS is a parallelogram with one angle 90 degrees. That means all angles are of 90 degrees. So I have PQRS is a rectangle. Fine, and that completes our discussion over all the questions. Here the questions can be pretty lengthy, but the concepts used are very, very nice and they require just a bit of logic and your clear understanding of each and every theorem, result and what to use when. So please practice all the questions nicely. That's it from my side. Thank you.